This video shows properties for a relation that has an infinite set of points. So here a relation goes from z to z, and a is related to b if a plus b is even. So there's an infinite number of values that could work for this, or ordered pairs. So 1, 1 is in my relation because 1 plus 1 is 2, which is even. But I could also have 1001 and 25. When you add those together, you get 1026. It's even. So there's an infinite number of pairs in this relation, so it makes it a little bit more difficult to think about these properties. The first property, reflexive, is AA in the relationship for all possible A's. So in other words, is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on, where the values are the same. So when you have a value, it's either even or odd, and because we know even plus even is even, and we also know odd plus odd is even, that means this is reflexive. So it cannot be irreflexive, but when the answer is no, we need to come up with an example. So for example, 1, 1 is in the relation. So because that's in the relation, it cannot be irreflexive. For symmetric, this is yes. And again, we don't have to justify the yeses, but trying to give you a reason why. It's because a plus b is equal to b plus a. So it doesn't matter what order you add, they're still going to be even. So asymmetric would mean if a plus b is in R, if ab is in R, then ba is not. So that's not possible, and then you can give an example. So for example, 2, 6 is in the relation, and 6, 2 is also in the relation. So because they are both in the relation, it is not asymmetric. For antisymmetric, you need to find two pairs that are in the relation, but yet their A and B are not equal. So let me give you an example. So this is no. For example, 6, 2 and 2, 6 are in the relation, but 6 is not equal to 2. And then for transitive, this is a yes, and you can look at some examples. So for example, if we have 1, 9, add those together, you get an even, and let's say 9, 5, they both, 1 and 9 and 9 and 5 both add up to an even. They are both in R, and 1, 5 is also in R. This does not prove it's transitive, it just gives you an example of kind of what it means. And you don't have to prove it's transitive, but the reason it's transitive is because in order to be in a relationship, you either are even or odd. So if that's my A and my B is even and even, then my B again is even. So my C must be even. And then if I look at the A and the C, if they're both even, then I'm in the relation. And you can do a similar argument for if they're both odd. Hope that helps.